In this lecture, we will discuss how to design an axially loaded column when its size is already known to us. Before we begin the design procedure, it's important to understand what are axially loaded columns and how to identify them in a building plan. In an axially loaded column, the applied load passes through the centroid of the section as depicted in this picture. In these columns, the beams surrounding all four sides of the column have identical lengths and cross sections. Consequently, the moments produced by each of the four sides are of equal magnitude, and the opposing beams counterbalance each other's moments. As a result, the overall moment effect is negligible. However, it's practically very difficult to cast an axially loaded column. Therefore, according to IS 456-2000, it's recommended to design a column by also taking into account a minimum eccentricity. The term eccentricity refers to the load not passing through the centroid, but rather deviating slightly from the centroidal axis of the column. Now, let's walk through an example to better understand the design process for an axially loaded column. Suppose we have a column of size 500 into 500 mm, a service load of 2000 kN, and both the ends of the column are effectively held in position and restrained against rotation. The unsupported length is given as 3 meters. We will be using M20 concrete and Fe415 grade of steel for this design. To begin, let's take a look at the given parameters. The width of the column B is given as 500 mm, the depth D is also 500 mm, and the unsupported length L is 3 meters. The unfactored load is 2000 kN, and we will be using M20 concrete and Fe415 grade of steel. To calculate the effective length, we will refer table 28 from IS 456-2000. Since both the ends of the column are effectively held in position and restrained against rotation, we can determine the effective length as 0.65 times the unsupported length L. Therefore, L effective is calculated as 0.65 multiplied by 3 meters, which gives us 1.95 meter or 1950 mm. Now, let's check the slenderness ratio, which is an important parameter for compression members like columns. It determines whether a column is classified as long column or a short column. The slenderness ratio is the ratio of effective length to the lateral dimension of the column. In our case, we have L effective as 1950 mm and the lateral dimension of the column, which is both B and D, equal to 500 mm. Calculating L effective by B and L effective upon D, we find that both are less than 12, indicating that the column is classified as a short column. Now, let's check for the minimum eccentricity. According to IS 456-2000, clause 25.4, all columns should be designed for a minimum eccentricity which is equal to the unsupported length of the column divided by 500 plus the lateral dimensions divided by 30, subjected to a minimum of 20 mm. In this case, the unsupported length of the column is 3 meters and the lateral dimension is 500 mm. Let's calculate the minimum eccentricity. Ex minimum will be equal to unsupported length upon 500 plus B upon 30, which will be equal to 20.56 mm. Similarly, Ey minimum will be equal to unsupported length upon 500 plus D upon 30, which will also be equal to 20.56 mm. According to IS 456-2000, clause 39.3, the minimum eccentricity should not exceed 0.05 times the lateral dimension of the column. 0.05 times D will be equal to 25 mm, which is greater than the minimum eccentricity. Similarly, 0.05 times B will also be equal to 25 mm, which is greater than E minimum. Therefore, the minimum eccentricity requirements are satisfied. Now, we can proceed to the member design by using the equation Pu equal to 0.4 FCK AC plus 0.67 Fy ASC, where Pu is the axial load on the member, FCK is the characteristic compressive strength of the concrete, AC is the area of concrete, Fy is the characteristic strength of the compression reinforcement, and ASC is the area of longitudinal reinforcement for columns. Now, let's calculate the longitudinal reinforcement. The gross area AG is calculated as the product of the dimensions of the column. That's AG will be equal to 500 into 500 mm square. As we know, the gross area AG is the summation of area of concrete AC plus area of steel in concrete, that's ASC. Or we can say AC will be equal to AG minus ASC. Now, let's substitute the values in the equation for Pu. Pu is equal to 0.4 FCK into AC, and we can write AG minus ASC in place of AC. plus 0.67 Fi ASC. On simplifying further and solving this equation for ASC, we will get the value of ASC equal to 3703.02 mm square. According to IS 456-2000, the minimum area of longitudinal reinforcement shall be 0.8% of the gross area, that's AG. ASC minimum will be equal to 0.8% of AG, which will be equal to 2000 mm square. Therefore, the required ASC is 3703.02 mm square, which is greater than the minimum required area. Now, assuming the diameter of corner bars as 25 mm, we can calculate the area of one bar. AST of one bar will be equal to pi by 4 d square, where d is the diameter of the longitudinal bar. Since there are 4 corner bars, the AST provided will be equal to 4 times AST of one bar, which will be equal to 1962.5 mm square. Again, assuming the diameter of the middle bars as 25 mm, the area of one bar is the same as the corner bars. AST of one bar will be pi by 4 d square, where d is 25 mm. Since we have already calculated the required ASC, which is 3703.02 mm square, the provided reinforcement is greater than the required value. ASC provided will be equal to 1962.5 mm square from corner bars plus 1962.5 mm square from middle bars. The total will be 3925 mm square. The percentage of reinforcement provided will be ASC provided into 100 upon AG. ASC provided is 3925, AG is 25 into 10 raised to the power 4, and the total will be 1.57%, which is less than the maximum value of 6%. In summary, for this column design, we need to provide 4 number of 25 mm corner bars and 4 number of 25 mm middle bars to meet the required area of longitudinal reinforcement. The percentage of reinforcement provided is 1.57%, which is below the maximum criteria of 6%. Now, let's design the lateral ties. According to IS 456-2000, the diameter of lateral ties should not be less than 1/4 of the diameter of the largest longitudinal bar, and in no case less than 6 mm, whichever is greater. We have determined that the diameter of the largest longitudinal bar is 25 mm, so the minimum diameter for the lateral ties is 1/4 of 25 mm, which is 6.25 mm. Let's provide 8 mm diameter of ties to satisfy this requirement. The spacing of the lateral ties should not exceed the least value from the following 3 criteria. The first one being the least lateral dimension of the member, which is 500 mm. The second criteria being 16 times the diameter of the smallest longitudinal bar, which is 16 times 25 mm. And the third criteria is 300 mm. As you can see, 300 mm is the least value among all the 3 criteria. Hence, we should provide 8 mm ties at a spacing of 300 mm center to center. Now, let's check for extra ties. Extra ties are required if the spacing between longitudinal bars exceeds 75 mm. In this case, the distance between 2 bars is calculated as spacing between 2 bars equal to d minus twice clear cover upon 2, where d is the depth of the column and clear cover is assumed to be 40 mm. The total will be 210 mm. Since 210 mm is greater than 75 mm, we need to provide extra ties. Now, let's check whether we need to provide open ties or closed ties. According to SP 34/1987, if the spacing between longitudinal edge bars does not exceed 48 times the diameter of the tie, open ties are provided. However, if the spacing exceeds 48 times the diameter of the tie, in such case, closed ties are provided. In our case, the spacing between 2 edge bars is calculated as d minus twice clear cover, which will be equal to 420 mm. Since 48 times the diameter of the tie is 48 times 8, which is less than 420 mm, hence we need to provide closed ties. To summarize, we will provide 8 mm diameter ties at a spacing of 300 mm center to center. Extra ties will be provided due to spacing between the longitudinal bars exceeding 75 mm. Additionally, closed ties will be used because the spacing between the edge bars exceeds 48 times the diameter of the tie. So this was all about this lecture. If you want the Excel sheet along with the manual calculation PDF of this topic, you can check out the link in the description box of this video. Thank you.